This podcast is sponsored by Lightstep. Lightstep delivers confidence at scale for those who develop, operate, and rely upon today's powerful software applications. Answer questions and diagnose 100% of anomalies, spanning mobile, monoliths, and microservices across every service in real time. Visit lightstep.com.
In 1911, New York City, there was a fire. 146 people died in 18 minutes. Called the Triangle Shirtwaist Factory Fire, some of the noted causes for the fire included a building, while fireproof for the time, so packed with clothing garments that it might as well have been made from cloth. A fire escape that literally collapsed under the load of people trying to escape the burning building. Ladders that the fire department used at the time reached the 6th floor, and the fire was between the 7th and 9th floor of the building. And an exit was literally locked, and the person with the key had already escaped the burning fire. Because of this fire, one of the worst fires in New York City history, 60 new laws were passed over the span of 3 years. The official National Fire Protection Association report on the fire also, for the first time, noted that fire escapes were a pitiful delusion when it came to fire safety. This fire began the process that ultimately outlawed fire escapes in New York City, though it took until 1968 before they were actually not allowed in new construction. But wait, as interesting as all this may be, this is a software podcast, right? What does the podcast have to do with the Triangle Shirtwaist Factory Fire? On today's podcast, Tanya Reilly, Principal Software Engineer at Squarespace, previously a staff SRE at Google, is going to chat with us about lessons from the evolution of the fire code in New York City and how these map quite literally to the software industry. Hi, my name is Wes Reisz. I'm the host of the InfoQ Podcast. The InfoQ Podcast is a weekly chat with some of the people typically speaking and involved with a software conference I chair called QCon. At QCon New York this past June, our guest today did a keynote called The History of Fire Escapes. You can find the full video online at InfoQ.com by searching for her name. While being an incredibly interesting review of how the fire protection laws have evolved in New York, her talk provided insights into software around things like load testing, failure domains, capacity planning, architecture, chaos engineering, and incident response. On today's podcast, Tanya and I talk about the role of an SRE, a site reliability engineer, and what we should be thinking about in our software systems today when it comes to effective incident response. TLDR, we should be building fireproof software. Thanks for joining us on the InfoQ Podcast. Tanya, welcome to the show.
Thanks so much for having me.
Where did this idea come from that you would kind of talk about SREs and site reliability in the relationship to fire escapes?
So I've been working on a project around disaster recovery, thinking about really bad infrastructure disasters and how we would recover from them. And when you think about disaster recovery, you spend a lot of time thinking about contingency plans or fallback plans. Like, what happens if your regular way of doing something isn't available? Like, maybe you get a key out of a fire safe, or maybe you fail over to another data center, you recover from backup. But the thing about contingency plans is they're what you do when the regular way of doing something doesn't work. By definition, it's less tested. So I was thinking about this a lot, and I'm walking around New York City, and it's in the fall, and it's beautiful, and the light is soft, and everywhere I go in New York City, I see fire escapes. The city is covered in fire escapes. And I started realizing that they were also contingency plans. These are the untested way of getting out of the building that you only use when you really, really need to get out of the building safely because something bad is happening. And so I thought, I wonder what the history of these things are. They're so ubiquitous. I wonder how they became the fallback plan.
So these fire escapes that are, as you say, ubiquitous in New York City are just fallback plans.
Right, exactly. And of course, I started reading about fire escapes and discovered that they're not even part of the code anymore. Since the 1960s, you can't build fire escapes anymore.
Yeah, as your keynote illustrated, they probably weren't the best fallback plan for the city. But before we get into that, today you're a principal engineer for infrastructure at Squarespace. What's the role of infra engineering look like at Squarespace?
We're a product-focused company. We make a beautiful platform for websites and stores. But underneath this beautiful platform, there is infrastructure, which needs to keep running and stay stable. My job is to make sure that we have a coherent story for where our infrastructure is going and why. I gave a talk to our interns a couple of months ago, and I was trying to think about how to describe what my job is. And in the end, I said, my job is basically to ask, why are we doing this? And have we written that down? You know, I joke, I will eventually replace myself with a Python script that does that, and then I can go ride bikes all day.
Nice. When you talk about working in infrastructure at Squarespace, what does that mean?
So I think if you're a developer making a product, You should have obviously some idea that there is infrastructure running underneath, but you shouldn't need to know all of the details of it. There should be a layer of abstraction, which is your infrastructure. And I think we think about infrastructure, or we should think about infrastructure more as a product that we're providing to the product engineering organizations who need to use it. Mm-hmm. So to some extent, the infrastructure should be almost abstracted away. Underneath there are operating systems that have kernels, and there are storage systems, and there are databases, and there is some job control. But all of that should be very well defined, almost like an API to your infrastructure with SLOs to tell you how reliable each part of it should be.
And before that, you were at Google. Similar type of work there?
I was at Google for 12 years. I started as a systems administrator level 1, which is pretty junior, working on internal HR systems. But for nearly all the rest of the time, I was a site reliability and infrastructure project. I was on teams that ran various parts of the infrastructure, like load balancers and the monitoring platform. And then I had this great cross-team project that I mentioned before, this disaster recovery project, thinking about how things were interconnected and the dependencies between them and making sure that we could turn Google back on if we ever turned it off, which is a pretty cool project.
So at Squarespace, do you have SREs? Do you have an SRE team, or is that just part of what infrastructure function?
Yeah, we have a bunch of SRE teams inside the infrastructure group. We manage and run a lot of infrastructure services. Like we've got a databases team, a networks team, a storage team, and so on. Think of ourselves as advisors on reliability to the company. We define what launching safely means.
So let's talk about that for a second. So as you're talking about infrastructure, I hear a lot of hardware components. I hear SRE. Is it just another name for ops?
If you were to ask a lot of recruiters, then yes. SRE was originally set up to be kind of an operations group, but operations as envisioned by software engineers, where the majority of the operations work would be automated away or rolled into the software development process. There is a strong association with SRE and the pager. I think very often if you ask someone what is an SRE, the first thing that they will come to is it's the people who carry the pagers, the people who run the software. But I don't think that's right. I think of operations, I know it has traditionally been a job function, but I think it's better to think about it as a kind of work. And the old model for doing the operational work was that I think software engineers would go and create the code kind of untroubled by the realities of the world. And they would create a product and they would hand it over. Or the metaphor was always they would throw it over the wall. And there would be a dedicated operations team who would take it and make it run. And they would be aware of production realities and things like monitoring and incident response and backups and so on. We've sort of moved past that now. I think DevOps and SRE came along and removed that wall. The removal of silos is one of the core tenets of the DevOps movement. But the industry has done a lot of good work as well in removing the operations work completely. We have done a ton of automation. Stuff that humans used to do manually is now done by robots. But I think we've also realized that often the best people to run a system are the people who wrote the system, who really know the code.
You build it, you run it, right?
You build it, you run it. So we increasingly have teams that create software who are responsible for the whole software lifecycle and who, in the beginning, when they're designing the software, think about it differently because they think about how it has to work in the real world. And they know they're the ones who are going to get paged if it fails. I think this is a better model.
So where does that leave SRE?
If every team is doing its own operations work, then there are a couple of ways you can approach this. You can have every team independently go and understand what ops work means, how to monitor. Every team can go research the monitoring solutions on the market and choose one and try and run it for themselves. I think the role of SRE is to define the way to do this right. There's this great talk by Mike McGarr. He was at Netflix, I think, when he wrote the talk, but I think he's now at Slack, about defining the paved road. He's not in SRE, he's in developer tooling, I think. That really resonated with me as the purpose of SRE. It's fine how to do things in a really reliable way and to set up the processes and the tools and to provide the services that are needed so that the majority of the operations work goes away and what can't go away is as easy as possible.
So I hear two things. You have one aspect that an SRE could be the service owner of a critical cross-cutting concern, something like logging or monitoring or something along those lines. And that could literally be an SRE team that are engineers. And then you also have this kind of consultant role that SREs may perform where they engage with teams to say, this is the SLOs that we have for the organization. They're almost like a kind of a production readiness consultancy within the company to make sure it's ready for prime time. Is that right?
Right. I think it's a role that involves a lot of education. What we're doing here is not magic. Reliability is something that we all should be thinking about to some extent. I always say we all should be thinking about security. We shouldn't write code and then sprinkle security on at the end.
Absolutely.
Everybody should have some base understanding of security. But still we have a security team whose job is to go really deep and really understand, whose incentives are to keep the site secure. If you were to say that every development team has to focus on a bunch of different things, then you've got competing incentives. Which is most important? We want to ship features. We want to have something that's really reliable. We want to be secure. All of these are, of course, really important. But when we say something it is vital that our site stays up, it is vital that our security is good, we put dedicated job functions to be the experts on that, whose job is to make sure that this is happening no matter what else. They can't get distracted.
So that paved road, it should take care. What are the abstractions that thing's providing? Is it like monitoring and logging, tracing and debugging, those type of things? What are some of the other things that are maybe not so really obvious that should be kind of thought about from the paved road?
From the start, when you're creating a new piece of software, when you're writing the initial design, I think even right there at the beginning, there are some standard questions we should be asking. What are the dependencies? Especially in a microservice world where it's quite hard to keep a full picture of how everything connects to everything else. What are you going to connect to and what's going to connect to you? And how will you know when it does? How will the system perform under load? How will it perform if we lose one of our sites? How does it fail over? What is the operational work?
How do you necessarily do this, particularly like in a microservice world where literally services are discovering new services and are coming up? People are constantly deploying. A few years ago, I'd give you a nice architecture diagram, and here's my 12 dependencies that connected to it. But in today's microservices world, we're loosely coupled. We're injecting things. We don't necessarily know everything that is interacting and is a supplier to my system.
This is one of my favorite topics, dependencies. There's a great talk by Dave Renson at SRECon 2017, where he pointed out that anything you create will eventually become a platform, whether you know it or not. He said, if you don't offer a way for other people to consume the data that you provide, they will just scrape your site. That they'll find a way. So you offer a standard way for people to use your service. If you offer a good API, people will use it. And you instrument your service so that you can see who's using it.
There you go.
Either you write metrics to a monitoring system. Maybe you do logging. Maybe you implement distributed tracing, though I so far haven't seen a lot of people who have finished implementing distributed tracing, so we'll see where that goes.
So I'm looking at it the wrong way, right? So rather than me giving you a document that says these are the 14 things that consume my service, I'm giving you a tool that says this is how you discover what's currently using my system. It's flipping. It's a version of control. I'm saying here's how I interrogate who's using my system.
Well, there should be a standard way to do it.
Right.
And I don't know if I would say that this is something that SRE should provide, but it's certainly something that they should be thinking about.
Should be asking.
And they should be asking, as should, an entire infrastructure organization. How do we know in the microservices world how our services are interconnected? We shouldn't have every team, figure that out from scratch. There should be a right answer. And that's what it really boils down to. For any question like this, there should already be a right answer. People shouldn't, in a production readiness review, we shouldn't say, how are you connecting to the database? We should say, are you connecting to the database in the standard way, which is documented over here?
Yeah. In this particular example, though, the SRE is not really saying, what are the dependencies? They're saying, how do you let me know what the dependencies are so that way we can discover this if we need to? It's asking the right questions to make sure that undifferentiated heavy lifting is happening.
Well, from one point of view, I almost feel like SRE shouldn't need to know about the dependencies. They should be making sure that they're discoverable.
Yeah, right.
They should be making sure that the people who are running the service, which in some places will be SREs, in that case, they certainly should know the dependencies.
That makes sense.
But where you're running something you build yourself, you really want to know that the people who will run the service, who built it, that they're thinking about the dependencies. And that the downstream people are aware that they're about to get this extra traffic.
So I think right there is where you just illustrated the difference between operations and SREs, right? Operations is going to say, what are the 5 things that you're connecting to, where an SREs may be saying you need to have something in your system that actually allows people to understand what the dependencies are. Have you, the developer, addressed that? How is that instrumented? How is that automated?
Right, exactly that. Yeah. So it scales a lot better. If you can say, how are you thinking about this, rather than tell me what the right answer is.
Then in the optimal path, it's helping to provide and build tooling for that paved road approach to doing something in a standardized way that helps developers kind of remove friction from the whole process. Makes total sense. So that is actually a really nice segue back to your keynote where you, in the history of fire escapes, again, on InfoQ, if you want to watch it, you talked about 4 different aspects of kind of this fire safety evolution in New York over like literally just a few hundred years. And you talked specifically about the idea of prevention, about detection, isolation, and response in kind of those fire safety concepts as they relate to software. So I want to shift a little bit and talk a bit about those. So the first one that you talked about was like prevention. So what does fire safety prevention have to do with the field of software?
One of the things I say probably several times in the talk is that our number of fires and especially our number of fire deaths didn't decrease because we got better at response to fire. It's because we got better earlier on in the fire life cycle. And one of the ways we did that was by making it harder for fires to start at all. For example, we started doing wiring inspections. We did public safety campaigns telling people, how to smoke safely, how to cook safely, and so on. And I see us doing a lot of really similar things in tech. Like we have our own wiring inspections. Like our test suites, our unit tests, our integration tests. We exercise our code before we make it live.
Smoke test it.
We did, yeah, we smoke tested. I like that. We run our own disaster experiments and chaos engineering experiments to see if things will go on fire. We're preventing fire by building with better materials. So this kind of goes back to what I was saying earlier about SRE being a lot about defining the right way to do things, about being a lot about education. We do our own public safety campaigns. When I came into the industry, the way we did config is that every config was hand edited by a human and no configs in any 2 machines were the same. Every operating system was installed probably from a CD by a systems administrator.
Oh, yeah.
We don't do that now. Or if anyone listening to this does do that, don't do that. We told ourselves that this was not best practice. We decided what best practice was, that it is configuration management. And we kind of socialized the idea that this is the right way to do it.
Okay, in the next section, you talked about sprinklers. Sprinklers, they detect a condition and they react to it. It's automation, right?
Right, exactly. They might react to it in a kind of a messy way, but the fire is out before it causes a problem. It's automatic response. And I think we can do a lot of that as well. We have what I think of as semi-automated response, or the kind of response that a human can do without thinking about it very hard, which is a step on the way there. Like we write playbooks or runbooks to tell us what to do in an emergency. Or we've got single-click rollback. We say, if software that has just rolled out is bad, we can debug why it's bad, but first let's roll it back as quickly as possible and recover. Right. So we have this kind of not quite automated response, but immediate response that doesn't need a lot of thought. Well, I think we can also do bigger response. Like, you mentioned sprinklers are automation. They're making the problem go away, then we'll deal with it. So we can automatically move traffic around, for example.
Yeah. Another great one that you had in there was isolation. In your example with tenements, we put up firewalls and we found out that using firewalls prevent the spread of fires. And we've found out that using firewalls probably isn't the best word to use in software, is it? Putting up fire isolation boundaries, these firewall things in buildings, restricted where the blast radius was. We can do that in software too, right?
Right. Fire safety made a lot of advances over the years. But from reading about it, it looks like the one thing that really changed the game was these fireproof interior walls. Whilst fires could still start, making them not spread. There's this, I mentioned in the talk, there's this New York Times article. It's a front page article from 1923 where they talk about 200 buildings that have fireproof interior walls. And they say for 6 years, there's been no loss of life by fire in these 200 buildings. Front page of the New York Times. 200 buildings have had no fire.
Crazy. I guess buildings were just expected to be death traps.
It must have been horrifying. Really shocking that this is that this is front page news. And those, of course, became the code. And we do the same with isolation now. I see us thinking about how to stop a problem spreading. We use sharding, we use circuit breakers. We try to limit the blast radius of a problem.
So back to that question then I was asking before about the role of an SRE. So is the SRE asking the questions to say, how do you isolate kind of the blast radius of an outage? Or is the SRE actually the engineer developing kind of those undifferentiated, kind of the Hystrix library or something that may be being used by a development team?
It really depends. The work SREs do is different in different places. And in some places, it may start with, we recommend you use this particular pattern. It may be that we're providing this set of libraries that we think you should use. As in a lot of infrastructure, there are now good solutions that exist. I think a lot of the time, we shouldn't be creating something new. We should be using and improving what's already there and making standards.
Right. Being kind of the trusted advisor, so to speak.
Yeah. And the people who have written it down. There's a strange amount of power in just writing things down and saying, this is how we think we should do it.
So we've talked about prevention, we've talked about detection, we've talked about isolation with interior fire isolation walls, not called firewalls, that kind of create blast radius or isolate it. But what about response now? So eventually at some time there's going to be an outage. What are SREs the firefighters? Are they the ones that are going to jump in there and kind of fight this battle, or what should they be?
SREs are occasionally firefighters. I think that is part of the job. And by that, I don't mean they should respond to every fire. In the same way that we don't have the firefighters respond to every fire. We have, you burn toast in your kitchen, or I don't know, you let something boil over. You don't call firefighters every time. So I think whoever's running the software, which again, in some places may be SREs, you build it, you run it model will be the people who built it. They should be able to respond to their own outages. I think the vast number of outages that require human response should be able to be trivially dealt with. Now, occasionally you're going to have something that crosses many teams, or maybe is just such a massive outage we don't even know where to start. And so I do like the idea of having people who are experts at incident response, who are called in for this. I can see the model where SREs are the firefighters of last resort, the people you call in when the outage is really bad and you want people who are experts at fighting fires. But it shouldn't happen very often.
If SREs is our consultant that we reach out to kind of help train and kind of evangelize the right way to do this incident response, what does a good incident response look like? What should it look like?
A good incident response has a lot of communication. Everybody understands what everybody else is doing. It's fast. It doesn't involve too much churn. There's not things happening all over the place, ideally. So it's a well-managed incident. The other important thing about incident response is the follow-up. So the problem has gone away. What do? Do you just go get on with your life? I really like the model of postmortems and blameless postmortems, especially, this is a fairly key tenet. I mean, it didn't come out of SRE originally, but we have wholeheartedly embraced it. The idea that after any outage, you do a retrospective where you really try to understand what happened. And you take actions out of that will stop the same thing happening again. And the actions may be fixing software bugs, but may also apply to the things that made the problem worse, like communication issues between people, or confusion, or documentation that was wrong, or documentation that was missing, or anywhere where people weren't quite sure what to do, or anything where someone did the wrong thing. Why did they do the wrong thing? Let's really understand the steps leading up to how that happened and make it so that next time they will do the right thing.
So what should be the outcome of a good postmortem? Is it a bunch of JIRA tickets that are things that we need to fix, or is it training? Is it all these things? What's the good outcome of blameless postmortems?
It really depends. I think there's likely to be some JIRA tickets out of everyone. There are some actions that will need to be taken to make the same problem not happen again. There's likely to be some education out of it. I like the idea of rerunning big outages as Wheel of Misfortune. Do you know Wheel of Misfortune?
Yeah, I do, but go ahead. What's Wheel of Misfortune?
Like you play Dungeons and Dragons with an outage.
So you role play it.
You role play it. You say, and then this happened. What would you do? And the person who is role playing, being on call at the time, says, I would page this person. Okay, how would you find them? How would you find their number? I would restart the service. What's the command you would type to do it? How would you find it?
So is this wheel of misfortune, is this like, once a month, once a week, an hour meeting where we just alternate? I'm in the misfortune seat and I'm going to be answering the questions and everybody's going to critique this. What does this wheel of misfortune look like?
I've seen it done different ways in different places. I've seen it done as done successfully for training incident commanders, as a one-off, or I think two sessions where the actual technical solution to the outage was irrelevant, or it was all written down on cards, which were handed out to the people who were supposed to be the experts. We're training incident commanders in how to respond under some pressure and how to decide what to do and to make sure that they're following a checklist and keeping the right notes and updating the right people. When we ran one of those, we had one person whose job was to be wrong and to interject at intervals with something that was unrelated to the incident.
Nice, love it.
The commander deal with handling somebody who is not actually contributing usefully to the conversation. Yeah. But I've seen other places where Wheel of Misfortune is a regular event in the calendar for a specific team, where every week or every 2 weeks they run a new incident.
Yep, very nice.
It's a great tool.
So what other tools do SREs employ, such as blameless postmortems, as Wheel of Misfortune? Are there any other tools? You mentioned runbooks earlier. Are there any other tools that are kind of at the toolbox for an SRE, a modern SRE?
Well, I don't think an SRE is allowed to speak publicly without saying the words SLI and SLO again and again, maybe even error budgets, so we should probably talk about them.
What's an error budget?
An error budget is a way of quantifying the amount of downtime you're comfortable with, for whatever downtime means for you.
Okay, so that should be nothing, right? Anytime I have this discussion with someone, our downtime should be nothing, so we should have a 0 error budget.
If you're running a pacemaker, then probably. But most systems are more complicated than that. There's this great quote from Ben Traynor, who founded SRE at Google, where he says, 100% is the wrong reliability target for basically everything, because it's incredibly expensive. Every extra 9 costs you a ton more effort. Yeah. Like if you say we have 5 nines of uptime, what you're saying is we're going to be down for less than 5 minutes a year. And the engineering effort required to be down for less than 5 minutes a year is huge. And if you are down for 5 minutes, especially if you spread it over some seconds every month, chances are your users won't know. Or in most cases, they'll blame their ISP. Or DNS. Everyone likes to blame DNS.
But how do you respond to leadership that says we should be striving for 0 downtime, whether that is our actual SLO or not? That's what we should be striving. So we can't have an error budget.
So that great Grace Hopper quote, "A ship in port is safe, but that's not what ships are for." We're writing the software for a reason. We're running it for a reason. There's something we're trying to do. And most likely we'll want to change the software to continue to do that, to do it better. And that will sometimes involve taking, ideally, very small risks. And we use error budgets and SLOs to quantify how much risks we're comfortable taking. So if we say we're comfortable being down for 10 minutes a year, and it's March and we've been down for 9 minutes, then that's going to inform how many risks we take or our development velocity for the next while. Conversely, if we're coming up to the end of the year and we have had no outages at all, then maybe we'll increase development velocity. Maybe we'll be comfortable going faster.
So software is becoming more and more a part of our everyday lives. Soon we're going to see autonomous driving cars on the roads. We're going to see control systems that are launching rockets and are landing those boosters again on drone ships. Of course, I Still Love You, I believe is what it's called. In your talk, in your keynote, you talked about fire code, and one of the things that you said was nothing really happened until a bunch of people had died. With how prolific software is becoming in our everyday life, how do we get ahead of this, and how do we move forward as an industry and keep creating more reliable, safer software without a whole bunch of people losing their lives before it happens?
We have to decide to care about this. We have a reasonably good idea now about what best practices are for software, and that will continue to get better. But nothing at all makes us follow any of these best practices. I would like us to have professional standards, and I'd like us to opt into following them. I really want a fire code for software. I want us to say, you must be able to withstand a fire of this heat for this many minutes, and only build with materials that can do that. I'd like to see us doing more public postmortems. A lot of places are now doing. I think that's really great. But I think every time we have a major outage, the entire industry should learn from it.
Certainly a challenge there, right? To be able to talk about human mistakes that lead to outages, that real humans are behind these things, at least in a very public forum. Definitely a challenge there.
This is why blameless postmortems are so good. We don't say, well, occasionally the newspapers do say, this outage happened because of user error or human error. And it is never human error, or rather we could say everything is human error because we're all humans. But nothing is just one person decides one day to try to cause an outage. There are a whole system of mistakes that happen along the way, things that should have stopped this person from doing what they did, mental models that they hold because we didn't give them the right information.
Absolutely.
And maybe the way that they panicked once they realized there was an outage and mashed the wrong keys. All of these are things that we can solve, but there's a whole system of things to learn from every outage. And I think we need to do that.
If there's one thing you want to leave listeners or what they can learn from the fire protection industry as applied to software, what would that be?
Can I have two things?
Of course.
Okay. So one is we need to consider software reliability throughout the full life cycle of software development. And we need to know the right way to do that. So we need a fire code. My first thing is we need a fire code for the whole thing. We can't sprinkle reliability on at the end. We can't make the response part be the way we keep things reliable. So when you think about designing a new system, think about how you would build it if there was not going to be someone on call for it. So try and have the pager really as the absolute last resort. But my second thing is get a smoke alarm. I've read so many horror stories while creating this talk. Please get a smoke alarm. They cost like $11.
Tanya, thank you for joining us on the InfoQ Podcast.
Thank you very much for having me.
Thank you all, too, for joining us on the podcast. If you enjoyed this podcast, make sure to watch Tanya's full keynote at InfoQ.com. And if you'd like to be part of the conference itself, the next QCon is in London on March 4th through 6th. Keynotes this year include Adrian Treneman, SVP of Engineering from the Hudson Bay Company, Sarah Wells, the Technical Director for Operations Reliability at the FT Financial Times, and a closing keynote from the award-winning writer, broadcaster, and doctor Ben Goldacre, who wrote a column in The Guardian, and his talk will be called Bad Science, Bad Data. Hope you can join us then.